Loud. All right. Blake, yeah, go ahead and take it away.
Awesome. Yep. So my name is Blaec Bejarano. I'm the Chief Sales Officer for CoCalc, but here with me, I have our CEO and founder, William Stein, and also Andre Novoselsov, our Chief Operating Officer. So feel free to ask any questions after my quick little demo. We're more than happy to answer any more technical questions that you have regarding Dask, et cetera. I know that there's some tooling that's particularly relevant and important to this group. So we're more than happy to facilitate that conversation, but I'm going to just give a nice little quick overview of the platform. So without further ado, I'll go ahead and share my screen. So let me go ahead and do that now. So you should be able to see my screen now. Please let me know if that's not the case.
Yeah, it looks good.
Fantastic. So right now I'm actually at CoCalc.com, which is our managed service. We also do have on-premises installations via Helm chart for your own Kubernetes instance. Just for folks that might be interested in something like that, but I'll go ahead and hop into the platform now. So you can see CoCalc essentially consists of projects. Projects are each just Docker containers. You can create multiple projects with different sets of collaborators to determine who has access to what files. And then I'll go ahead and pop into this public demo that I'd created. And here you can see I've got some GIFs and some other things like that that I've created inside of my Linux file sharing system. So CoCalc is essentially a shared desktop platform. So you can easily add your collaborators via their email address, and then they'll have access to all the files inside of the shared Linux file sharing system. And with a click of a button, you can use any of your favorite application types. We really go with more of an open world approach for computational software. So we really don't want to hem anyone into using any kind of particular programming language or environment. So you have the ability to use our custom Jupyter Notebook interface. You can also use a Linux terminal, LaTeX or Markdown documents for scientific publications. And here's our nice little LaTeX editor just for that. So you can see here, I actually created a nice little LaTeX template using our AI integrations, and I went ahead and copied and pasted that in. So if you've ever used something like Overleaf, this should look fairly familiar to you. One key aspect that I would say that kind of differentiates our LaTeX editor is the fact that you can actually run code using the package Python tech or using the package Sage tech, write a line of Python code and immediately have your plots or visualization show up inside of your PDF, which can be really nice without having to port those images over from some external file. The other thing that I'd want to mention too is that we support folks that want to use traditional code servers in addition to our custom Jupyter Notebook interface. So if you have that built-in muscle memory, you can absolutely use Jupyter Classic or Jupyter Lab. You can also use VS Code, Pluto for those Julia fans out there. You can use Rstudio environment, and we do also have X11 graphical desktop for your own custom IDE. We were born out of the University of Washington Mathematics Department, so we all have backgrounds in pure applied mathematics, which is why we have this integrated course management system. And the integrated course management system actually supports automatic grading of Jupyter Notebooks via NBGrader. So you can get back to doing the research rather than tediously grading a bunch of notebooks. So for folks that are asking how we might be able to, for instance, use Dask in a course, we do have this really nice course management feature with a configuration tab that allows you to configure really any of the aspects of your course that you'd need to in that capacity. And CoCalc was actually born in 2013 to eliminate the installation and package maintenance issues often associated with open source software like SageMath, which is the open source programming language that William had created in 2004 as an alternative to MATLAB, Mathematica, Maple, and Magma for computational symbolic algebra. So that's us. We're SageMath Incorporated, and CoCalc is our platform. The other thing that I'd want to quickly mention here too is that we're the first company ever to come out with a computational whiteboard environment in slideshow mode. So it's a fully featured whiteboard where you can write using a pen and a tablet like your iPad. You can make some sticky notes in LaTeX, Markdown, or rich text for some math notation. So here you can see I can easily switch back and forth between Markdown with LaTeX compatibility and this nice rich text editor. So let me go ahead and do that here. So Markdown with some LaTeX, nice little rich text editor for folks that may not be comfortable using LaTeX or Markdown. And then here's where things get really interesting. You can actually run Jupyter cells directly inside of the whiteboard environment in any of your favorite programming kernels with no installation required. And we support all of them. You can use Python or R. You could also use Julia, Octave, C++, JavaScript, Bash, Rust, SageMath, custom kernel environments. You even have version control for the kernels themselves. So if you have that one pesky package that's only running with Python 3 and Anaconda 2022, you can just select that kernel. You're off to the races. You're not going to have to go deal with any kind of package dependency issues. But personally, what I would tell you guys is that we are most well known for our custom Jupyter Notebook interface. So the one thing I'd want to go ahead and emphasize here is that everything inside of the platform is real-time collaborative and computational, and that includes the side chat functionality. So you actually have the ability to, let me go ahead and see what's going on here. So let me go ahead and click on this guy. There we go. So you can see I've got my nice little Jupyter Notebook here, and everything's real-time collaborative. You can see each other's cursors moving around. You can see each other typing in the script in real time together. But you also have this nice side chat functionality. In fact, I'm sure William will end up typing something over here. But at any time, I can call my colleagues over and I can say, hey, William, check out what I've been up to today in my script. Feel free to leave some annotated comments and feedback or contribute directly to the script with me in real time. And if you don't have a colleague available, you also have any of your favorite large language models that are immediately available at your disposal. And you have the ability to use both free and premium models, GPT 3.5, GPT-4, Gemini Pro, Mistral, or Claude 3 by Anthropic. So depending on what your use case is, or maybe you want to evaluate what the output is for various LLMs, you have the ability to do that while using our APIs. So you're not going to have to go set up an account with OpenAI or something like that in order to be able to use this. And everything's metered per token, so you can definitely save some money and be cost effective in that context too if you're using one of the premium models. But here you can see that William was in fact writing just less than a minute ago and said hi. And the other thing that I'd maybe want to go ahead and point out here too, just for fun, is you can actually run code cells directly in the side chat. So here I'm going to go ahead and use GPT-4 Omni 8K, and I'm going to say something like, I don't know, create me a script, script that solves the, let's say, the wave equation using finite differences. We'll just do something pretty standard. Let me go ahead and correct that. So I'll go ahead and ask, and now it's going to produce this script for me. And you actually have the ability to click run and make sure that that generated code is giving you the plots or visualizations that you'd expect before you actually port this generated code over into the production level notebook on the left. I'll go ahead and do that now, just for fun. We'll see if it worked. There we go. I got this nice little plot here, and then I can easily copy, and then I can paste this over with the click of a button, and then I could, of course, run it here as well. And you'll see that nice visualization that's going to show up. So that's one nice little quick thing with our AI integrations. The other thing I'd want to go ahead and showcase here too is our AI tool functionality. You easily have the ability to explain a code cell. You can bug fix, you can modify, improve, document, or even translate to another programming language. For instance, if I love Jupyter Notebooks and Python, maybe I want to go ahead and translate this to R because I have a colleague that wants to be able to use that programming language. You can also select anything else that you'd like listed here, including MATLAB. So here I'm going to go ahead and ask, get a nice little overview of how to rewrite this code in R. And then I can, of course, test it here using this programming kernel by clicking run. The other thing that I'd want to mention as well is we have this nice little GUI editor. So it says document aware as you'd like it to be. You can use a selection of cells, a particular cell, all of them or none of them. You can pick a nice little example to get started with. And then you also have, of course, the ability to do full-on prompt engineering, and you can select whatever large language model that you'd like to use here. So these are just some really nice little carrots that help enable folks to be able to utilize artificial intelligence inside of the Jupyter Notebook interface. The other thing that I'd want to go ahead and point out here as well is you have the ability to easily write using text cells with Markdown and also LaTeX compatibility and this nice rich text editor as well. Maybe you'd want to go ahead and video chat with your colleagues. You also have the ability to split your screen. You can look at multiple portions of your code all at once. Maybe you want this to be a Linux terminal. So CoCalc really helps facilitate a programming environment, not only for folks that have a traditional computer science background that feel comfortable using a Linux terminal. You can push, pull, and commit to your favorite repositories using Git. You can use any of your favorite Linux commands. I'll go ahead and use ls here. Maybe I'll also want to go ahead and use top. But in addition to being able to use Git for version control, we believe that that version control is important for everyone, not just folks that have that traditional computer science background. So you also have the ability to use our custom TimeTravel implementation, which is just really fantastic. You can literally rewatch everything that's occurred from the initialization of a document up to its current state. Fine-grained resolution every 2 seconds, everything's recorded. So you'll see me handwriting these lines right here. And you can say, oh, hey, Blaec, I see what you were doing here up to revision 36 out of 170, but we might want to consider doing something just a bit more like this. Or, hey, we horribly broke our code. Let's go back. We'll revert to this previous version. We can build on top of that. And if you're really lost in the weeds, you can't figure out what's went wrong for the life of you, you can actually use change diffs to see exactly which changed in JSON format between any 2 points in time. And then you can iterate throughout the document in that sense too. So long gone are those days of having to search for where you left an H out of plot show. For instance, here, maybe I'll want to go ahead and delete this and I'll rerun this code cell just again for fun. And it's going to say, hey, you've got an error. And I could say, hey, help me fix this. Ask, you wrote plot sal, not plot show. You're going to want to go ahead and get that corrected. And here's that corrected version of your code. And then lastly, if I want to go ahead and explain this nice little functionality, get an overview of the underlying architecture of the problem, what each of the variables, components, and packages do, you can, of course, click that AI tool explain button there. Now, the thing that I'm personally the most excited about for our platform at this time is our new compute server functionality. So essentially what compute servers are, this is an escape hatch from our Kubernetes cluster that runs on Google Cloud. CoCalc is actually cloud agnostic. So you can run CoCalc using on-prem on whatever cloud provider you'd like of your choice. And then if you're using our managed service, of course, you're using Google Cloud that's running over on the US East Coast. But compute servers actually allow you to spin up arbitrarily powerful machines from any of your favorite cloud providers. And you can also use your own on-premises resources. We have some really tight integrations with Google Cloud and Hyperstack, but I also have the ability to use maybe like an AWS console, for example, by clicking on the on-prem button. Then I spin up a virtual machine in my AWS console, and then I would copy and paste a single line of code into my terminal there. And we actually use an Internet of Things approach to allocate those resources from your virtual machine directly to your CoCalc instance, all via WebSocket. But just as a quick little example, I'm going to go ahead and showcase our nice Google Cloud integration. So here you can see you have spot instances to do batch processing. You can also run production level workloads with a standard instance, but I want that 83% discount whenever I can. You also have GPUs if you need them. You can choose the exact GPU type that you'd like to run your script with, the number of GPUs that you'd like to have concurrently running. And then you have your favorite machine learning software immediately available with a click of a button. It just works. You have PyTorch, TensorFlow, Google Colab, Llama, CUDA, and JAX, and Anaconda. You also can choose the exact machine type that you'd like to run the GPU with. Maybe you want a standard 16 with 64 gigs of RAM. And you can choose the exact location of your data center. You can meet whatever kind of bureaucratic constraints that you have to contend with, whatever kind of technical constraints. Maybe I want to reduce latency by having my data center located physically near me. Maybe I want to have lower carbon emission rates, or maybe I just want to be as cost effective as possible by choosing the lowest cost location. You can, be able to modify this for whatever kind of purposes and intents that you have. And everything here is metered per second. So you can see this listed cost per hour. So you can actually stop or suspend your instance at any time. You're only paying for the resources that you're effectively using. And then your data is stateful by default. So you're only paying for that disk space in the background where your instance is stopped or suspended. And when you're finished with that data, you can deprovision your instance at any time in order to forego any kind of costs in that capacity. The other thing that I'd want to go ahead and quickly point out as well is that you have up to 65 terabytes of disk space through Google Cloud to be able to host your data, up to 100 terabytes through Hyperstack, and you also have H100s that are immediately available, and you can see exactly how many are currently available in Canada right now, 308 to be exact, starting at $5.61 an hour. And then, of course, you have a whole host of other GPU types. And Hyperstack is actually a GPU cloud provider, a next-gen cloud that's based out of the United Kingdom. And what's really unique about Hyperstack is that their data centers are fully sustainable. They're completely powered off of geothermal energy located in both Canada and Norway. So those are some really nice alternatives to be able to use for folks that are concerned about sustainability and things like that. The other thing that I'd want to quickly point out for standard CPU machines is that you have the full machine spectrum with your favorite software images like Python, SageMath, Anaconda. You can use high-performance computing environment with Fortran and Slurm, Julia, Rstudio, Jupyter Hub, Lean, or a Kubernetes node. And then here you can see that that spectrum of machines goes from an incredibly small and inexpensive E2 micro for less than a penny an hour, all the way up to the most beefy, powerful machine that you'd ever probably want from Google Cloud, with almost 12,000 gigs of RAM and 416 CPU cores. And now when I want to run a script using this particular machine that I'd spun up, and configured myself, you could go ahead and click on the server button. Right now, it's using shared resources on our Kubernetes cluster on Google Cloud. And then I would go ahead and click on one of the compute servers that I'd configured to be able to have root access. I can install any of my favorite proprietary software in addition to the open source ecosystem that CoCalc provides right out of the box. And then I also have, any kind of dedicated resources that are outside of the amount that we're able to allocate from our Kubernetes cluster. So that's essentially how that works. And again, we really go with that open world mentality. If you have data that lives somewhere, you can use SSHFS, you can use Google Cloud Storage or Amazon S3 buckets, you can use API keys, SSH keys. Again, we really try and not hem anyone into anything particular. You can always move, your scripts or data in and out of the system. So you're not locked in like a vendor lock or anything like that. And then the other thing that I want to go ahead and say here too is that this is the list of file extensions that CoCalc supports right out of the box, and it's pretty much everything under the sun. If there's something that's missing, that's part of your everyday workflow, we want to know about it and make sure that we're supporting the community the best that we can. We really have a vested interest in helping break down the siloing that's happening not only within academia, but between academia, industry, and government by allowing folks to immediately become productive by using the tools and applications that they know and love, that they've developed on throughout their educational experience or throughout their career, but easily be able to compare results and write publications with folks that have a different niche workflow from your own. And the other thing maybe I'd want to go ahead and quickly point out here too is the fact that at any time you're easily able to publish any of your favorite files, including scripts like Jupyter Notebooks, etc. So what you go ahead and do is click on that publish button, and then you can have it private. Only collaborators that I explicitly add to my CoCalc project have access. I can have it public and unlisted. I can send someone that URL link, and then they'll have access to that file. Or I can have it public, listed, indexed via Google, and then it's publicly available on our CoCalc share server. And something that I'm particularly excited about right now is that we're working with Cambridge University Press. We host the Journal of Fluid Mechanics, and we're hoping to get some traction with some other journals and texts. So just as a quick example or a nice little bit of context here is, so you can see I'm at cambridge.org, and while I'm actively reading through the journal, you could see a nice little plot or simulation that looks relevant to your own research, and then you can actually click on that hot link. It'll take you directly to the CoCalc share server. And one thing that I'll want to go ahead and do really quick is click on this guy so we can wait for that. But here you can see you actually immediately have the Jupyter notebooks and data sets that belong with the research paper. You can edit your own copy, change some parameters, run that full-scale simulation. Let me go ahead and do this. I don't know what that was all about. Okay, so that seems bad. Let's go ahead and do this. Maybe here, I'll go ahead and click on this. Okay, so here you can see that there is a nice simulation that you can immediately take advantage of, and you can actually interact with these plots and simulations in real time. So long gone are those days of having to use the same 4 static time series plots. You can immediately be utilizing these scripts and data sets for your own research purposes without having to rebuild everything from scratch, compare the results, and then modify it for your own purposes. You actually skip that entire first portion of the process. But yeah, you actually have the DOI and other things like that that are associated here. But I want to make sure that I leave ample time for any kinds of questions specifically regarding the tooling that you guys are most familiar with, like Dask. So I'll go ahead and end my hyper demo there. But yeah, we're more than happy to answer any technical questions, and we've got our dream team here on the line to be able to help facilitate any inquiries that you have in that capacity. So thanks so much for your time, and I appreciate you taking a quick look at my CoCalc demo.